So I have a few more minutes of setting up, but I'm going to do that after I explain what we're talking about today. And that way, hopefully, there will be a few questions that I can try to answer while I finish setting up VR. So let me just open up my slides. See if that comes on. Great. So you are here today to learn about CLEVR, which stands for Collaborative Learning Environments in VR, and we are teaching cell biology to high school students. Is everyone in the right place? Great. Okay, so the next several slides are a graphic novel style introduction to the story of the world. And the important thing for you to know is that this is a 2-player collaborative game. So you can see the player 1 and player 2 on the different people's shirts, and they're talking about how this is their first day at their new research internship. So they're at a research hospital, and they're in the nanorobotics lab. And they're playing with all the cool tech, including there's a VR headset that is connected to a microbot. And they also have some kind of rodents in the lab. So the rodent decides that the microbot looks delicious and runs off with it, and that's how we get to the next lab. And in the next lab, they are looking at genetic diseases. So they meet this new doctor in this other lab who is ominously wearing a hazmat suit. They are not wearing hazmat suits. They wonder if they should be wearing hazmat suits. But the doctor sort of ignores it, so they're like, all right, maybe it's okay. And the issue is that there's a patient with a genetic disease, and the doctor in this lab would like to experiment with the microbot to see if that could help diagnose it. But the doctor doesn't know how to use it because it's brand new tech from another lab, so that's where the research interns come in. They also don't know how to use it, but they haven't said so. On the left, you can see the combination of the VR headset, microbot, and then on the right, there's this tablet type device with a different interface. And so it's sort of setting the stage that people will be working together across different technologies. So, doctor says, go into the cell, send the microbot into the cell, take a look around, see if you can figure out what's wrong with it, make a diagnosis, let me know what it is, good luck. And that's the end of the story. And then we send players into the game. So these are actually 2 of our MIT undergraduate research assistants. I should say that I work at a lab here at MIT called the Education Arcade. We're over in Tech Square, and we work with students. So, welcome. Temi on the left and Therese on the right are demonstrating what it's like to play this game together, and you can also see both of the interfaces on this screen. So the image in the middle on the monitor is what Temi is seeing in VR, and then Therese is using this Surface Pro as a touchscreen tablet. And it can't be just any touchscreen tablet because it only runs on Windows right now and it needs a very performant computer. It's a research project, so that doesn't bother us. But you can see they have different interfaces, but they're looking at similar things. So they both have a view of the cell, but they have different views of it and different tools and reference material, which encourages them to communicate and share that information with each other. So the next few scenes are screenshots from the tablet interface. So just introducing what you can do from that role. You start off, everything is grayscale. And that's because the tablet player can colorize things. So you see in the lower right, there's this little microscope icon. And then if you click it, it opens up this panel of all of the categories of organelles or proteins that you can colorize. And we've tried to have, as much as possible, this be authentic or at least plausible. So this colorization technique actually is based off of a real new microscopy technique that came out just this year from the University of Illinois. It's called slamming. It's a mouthful of words which I can say, but probably won't mean much to most people, including me, before I heard about it. Simultaneous, label-free, autofluorescent, multi-harmonic microscopy is what it stands for. And basically what it means is you shine a light at the cell, and it hits something and it bounces back, and that's not the light you see. It goes through some mapping process. And the reason for that is that some of the things that are interesting to see in cells are smaller than the wavelength of visible light. So if you're only shining visible light on them, you won't see them at all. It'll just go right around it. So you can shine an ultraviolet light, for example, at something and have it bounce back, but then you can't see that without some kind of digital mapping process. So that's really what I'm describing here. Then in the upper left, there's a sort of document icon, which is our library of cellular knowledge, or LOC. And what the information that's in here is possible diseases. So it's a very open-ended experience. We don't tell players what to do really, more than just you're trying to figure out what's wrong with this cell. And these are high school students, so they probably don't know that much about cell structure and processes yet. So they're likely to get overwhelmed and lost. So this is basically the support. Like if you feel lost and you don't know what to look for, come look here. Here are some clues of things that you can check for. So there are 5 classes of a disease. We picked cystic fibrosis because I believe it's the first disease that has an FDA-approved gene therapy. So again, as we were trying to be more authentic in our representations, we wanted to pick something that was real. And cystic fibrosis does actually have 5 classes of disease. So these are different ways that the cell can be broken that all lead to the same disease. But they have different therapies potentially, so you have to make the diagnosis before you know how to fix it. And then there's also a reference of healthy cell information. And then in the lower right, the little medicine bottle pulls out a tray of possible therapies. So this is basically how you win the game, as you select a therapy, and then you get to see through another outro comic narrative whether the therapy that you selected resolved the issue that this cell had. So now I'm going to show a couple of videos of the VR side. This first video is at microscale, so you can see the larger structures in the cell. There's no audio. So it starts off grayscale, and that's because it's the tablet player who has the ability to colorize for both players. So now that you see the colors coming on, that's because the tablet player is turning on those icons. And that's at the end of this video, which is right now, where all the teal blobby things come in. Those are proteins that make it very difficult to see the macro structure of the cell, but they're combating a misconception that people have that cells are just empty space, you know, and I'll talk more about that later, but we're trying to give a more realistic sense of what cells look like. I don't want that video again, I want the next video. This video takes place at nanoscale, so we actually have the microbot that you send into the cell has a little nanobot attached to it that you can deploy, and that's our way of transitioning between scales. I can talk more about that. We tried to transition smoothly between scales, and it was actually confusing for players whether sizes were changing or distances were changing. So because of that, we made a discrete transition with a separate bot. So we start at microscale, and now we went up to the ER, the rough ER, endoplasmic reticulum. We transitioned to nanoscale. Now we're right on the surface of the rough ER. The red things are ribosomes, which are translating strings of mRNA and creating other strings of amino acids, which is what we're looking at right now. And we just went inside the ER. We went through a translocon, which are the blue sort of window or doorways. And so in observing this translation process, we can see whether we think it's creating healthy functioning proteins or not. So the learning goal here was cell processes, cell structure and processes, but processes are more the focus at the high school level. And one of the more important core processes is called central dogma. It's DNA transcription to RNA translation to proteins. That's where a lot of the stuff in the cell comes from. Some stuff does come from outside of the cell, but a lot of the things that the cell makes goes through that process. So we wanted to start with a genetic disease, so it would allow us to focus in on that process. Next slide. All right. I will go quickly through the next bunch of slides, which are talking about the research side of the project, and then I'll go back to setting up the VR computer while I take questions, although you can interrupt if you want at any time. And my hope is that if any of you are interested in actually trying it, that then there'll be time for you to come down and try it out. So, collaboration. These are images from a technical school that we went to. It's called the Gloucester Biotech Academy. That's a year 13 program. So high school graduates who are preparing to be lab techs go here, and so they're learning a lot of the concepts that we would want to teach, and so we have done some testing with them this fall. Here are some images of different pairs of students collaborating with each other. You see the woman in the upper right holding a piece of paper. That's just because we didn't have time to get all of the information into the digital version, so we supplemented. We collected different kinds of data, audio and video recordings that we then did transcriptions of, and codings of different kinds of exchanges between players, because we're actually teaching both cell biology and collaboration. So we're looking for evidence of improving collaboration as well. And we had people draw a cell on paper before and after this experience to look for more nuance in their thinking about cell structure. So here's an example of, we actually started looking at an auto transcription, but it didn't do very well, partly because our audio quality wasn't good enough, and partly because of the terminology that people were using. So, yeah, don't forget to adjust the chicken. So then we went to a more manual transcription process. Yeah. The word transcription means two things in this talk, so don't get confused. Transcription means DNA being copied to mRNA, and it also means taking audio speech and writing it down. So we're coding things like first communication, using biology terms to describe something. And the learning outcomes were mainly, we could have collaborated better. So at the moment, this is a prototype that is playable once if you solve the puzzle. If you don't solve the puzzle, you can play it forever because you have more puzzle to solve. But once you've solved it, you've solved it. So someday we would like to make it replayable. And one of the main reasons to do that is that people have, once they play it once, they say, oh man, that was a great way for me to realize how little I know about collaboration. I'd love to try again with a new strategy. So that's one of our goals. And in terms of biology, as we expected, people saw that cells were more complicated and more full of stuff than they realized before. So this is describing the stages of how people make sense of the space. So orientation is talking about how when they first get into the cell in VR, basically they're not at all focused on the game goal. They're just like, whoa, where am I? I'm in this new world. What's here? What can I do? And that takes a few minutes. And then they have already forgotten about what the game goal is. And so us as facilitators remind them, but in the future we hope that we can create more supports within the game so that it can be a less facilitated experience. And then they start to develop some hypotheses, they collect some evidence, they discuss with their partner, share information, and hopefully come to a diagnosis. And also develop a shared language of how to talk about this. Some partners use more biology terms, which we do introduce to them. They don't have to know those ahead of time. There are labels and things they can get. Sometimes they'll just describe the way something looks, like, oh, the stringy thing, or the big blob. So here's an example of communication where they're actually using both color and the biology term. And then, I guess, coffee beans is more about the shape of it. So they stayed engaged throughout the experience, and in fact, this image in the upper right is after the time was up, because it was in school, so we had a fixed amount of time. We said, it's time to stop, but they hadn't solved the puzzle yet, and they had to get off the computer, but they still had that paper that we had printed, and they sort of put their heads together to try to figure it out even after finishing the game. So in terms of the biology side, this is the view on the left, which we call the Whitman sampler view, is basically what people see in the classroom. They see, it might be 2D, it might be 3D, but they see a representation of a cell that has all of the elements discretely labeled. They're maybe disconnected from each other. It's not an accurate representation of the size or number or position or orientation of these things. So it leads to a lot of misconceptions. It's good if your goal is to pass a quiz that says what are the elements in a cell. It's not good if your goal is to think about how cells work. So when we asked people to draw a picture of a cell before and after, we got pictures that look pretty similar to what they've seen in the classroom. I'm going to skip over the text. So here's an example of someone's before and after drawings, where the before is on the left and the after is on the right. And as you can see, the drawing on the right has more detail, more complicated structure. For example, the nucleus is very close to the ER and the Golgi body, whereas on the left, you see the nucleus pretty much by itself. And the ER is way on the other side of the cell, and there is no Golgi body. So there's no sense of how things might be working together. Also, all of the stringy things on the right, which are probably microtubules, are just totally missing on the left. And there's cilia on the right, and also the sense of size and number is much better on the right. You have like the vacuoles that are these tiny little dots, whereas on the left, they're basically the same size as the ER. And you have a more accurate number of things. It's still not very accurate, but it's more realistic. So we're moving things in the right direction. So here's just some data from different tests that we did. GBA stands for Gloucester Biotech Academy. That's the school that you saw the images from. MIT is just people that we brought into our lab to test out. And then the Boston MSHS comes from a variety of things, partly from the MIT Museum. We had an exhibit there and did some testing. So here's some more images, pre and post, to show how people's understandings of cell structure have evolved. And people liked that it was hands-on. And so this is not the end of the talk. This is where I now transition to the VR computer, which will take me a few minutes to keep setting up. But now I'd love to take questions. Yep. So, yeah, you guys focusing on valuing more? Yeah. So the primary learning goals of the game as a piece of software are cell structure and processes and collaboration. The primary goals of the project, it's a research project, so the product may never actually get to the state where it's polished enough that it scales. It may get to the state where it's polished enough for us to bring it into a few schools and collect some data to answer certain research questions, which are related, like how well are people improving their knowledge of cell structure and processes? How well are they collaborating? It's also partly how can VR be implemented in schools? And it's also partly how can we represent biology in a more authentic way, and also a more cutting edge way. So I'll tell a story at some point, maybe now, about how trying to create a realistic cell has been difficult for us. So we started with cystic fibrosis, which we knew took place primarily in ciliated cells. So it's in the lung. There's epithelial cells, which are the cells that are exposed to the air in the lung. And some of them have cilia on them, these little like strands that help move mucus and other things through the lung. But in patients who have cystic fibrosis, there's an imbalance in concentrations of ions, but inside the cell, outside the cell, and it creates this sticky mucus where the cilia can't move. And so we had this full understanding of how this disease works, And then because we were trying to make it authentic, we were looking for subject matter experts. And the good news is we found the right subject matter experts. The bad news is, or the complicated news, is that they said, actually, you're in the wrong cell. We just discovered a brand new type of cell that no one knew about before called an ionocyte. And we're writing a paper that isn't even published yet, but it'll be out next week. And we said, great. So we'll spend next summer remodeling our whole cell. So that is also part of the research project, is thinking about to what extent do we want to be on the cutting edge of science? How can we best capture that kind of thing? And the therapies as well have evolved since we've started the project. So basically, we're developing the game at the same pace that the science is evolving. So it's like a treadmill. Good question. All right, I just have to set up the Guardian system and the sensors. Other questions?
The device, I don't know if it's called like the device co-op between the tablet and the PC. I thought that was really cool. How did that happen? Or like, what was it about that?
There were a few thoughts behind that. One of them was classrooms are likely to have a bunch of different devices of different affordances. So we say it's a heterogeneous device ecosystem. And if we assume that classrooms will have all of the latest hardware all of the time, and they'll have enough of that hardware for every student to have it, I think that'll cut out a lot of schools. So as part of thinking about how we could make this work in real live schools, we were thinking about how can we take advantage of different hardware that the school might have. So assuming that they won't have an Oculus Rift, for example, for every student. Now that may prove to be false with something like the Vive Focus or the Oculus Quest or some of these other devices. There may be schools that do end up having one-to-one with students. But we didn't want to assume that every school has access to that hardware. We also didn't want to assume that every student can or wants to go into VR. So as soon as you talk about going into schools, you have to think about equity and accessibility. And if you come up with something that only works for a percentage of the students, but not all of them, the teacher may say, like, well, I really don't want to exclude a quarter of my class, so it's not going to work for me. And in our tests, we did find that there were people who didn't want to go into VR for whatever reason. They say, oh no, I know that I get car sick really easily, I just don't want to take a chance. Okay, let's see. Oh, can I skip that? I hope it remembers what I just did. I didn't want to do the in-headset part. I wanted to do the game. Other questions?
Yeah, on the heels of the last question, did you have a chance to explore or consider exploring what the differential is in learning gains between using the VR medium versus having a similar experience at the microscale and nanoscale, but just on a flat screen, using a laptop or a desktop computer or a tablet?
Yeah.
How much gain does it buy you to have a fully immersive VR experience?
That is a great question, and we don't fully know the answer to that. Because it's a research project, we have to pick our research questions, and there are always more research questions than we can focus on. So we felt like that is, in some ways, such low-hanging fruit to say, like, is VR better than not VR, that we thought a lot of people are focusing on that kind of question. And so we went a little bit deeper and said, beyond like, is VR good, to what are the best ways to design for VR and how can it fit into the classroom. But we also have the cross-platform. So we do have people using the 2D screen, even though it's showing 3D models. I don't have a great vocabulary for talking about that, because we often talk about 2D or 3D, but I feel like those words are a little bit ambiguous. So we can compare what people are learning from the tablet role versus the VR role, but they are not the exact same role. So there's lots of confounding factors there. I think at some point we could say it is the exact same role. You're just doing it on the PC with a headset, or you're doing it on the PC without a headset, or on the tablet, and compare all of those. That's something we've talked about doing and has not made it to the top of our priority list yet. Good question. Other questions? Okay, so I will show the game for, let's see. First I need to connect them. I'm just gonna give you a tour of the game for a couple of minutes, and then I'm going to ask for volunteers, anyone who wants to come down and try it out. The reason I'm restarting it is it wasn't connected to the same server. Oh, that's actually not what I wanted. I wanted to skip that scene. Okay, great, we're connected. Actually I'll ask for one volunteer first to start with the tablet. Is anyone interested in piloting the tablet? All right, come on down. So these buttons here will control the color.
Okay.
And I'll ask you to just turn those on one by one after I go into the headset.
Okay.
Okay, let me get to one end of the cell. Okay, go ahead.
All right.
All right, you just colored the
Membrane.
membrane, and I can get some information about that. Cell membrane, lipid bilayer that surrounds and protects the cell.
Okay.
Great. What else you got?
All right, let's try this one.
Ah, that is the centrosome and microtubules. So these microtubules are stringy things, cylindrical tubes. They help in cell division. And it doesn't actually say this on the clipboard, but it helps in transport as well.
Mm-hmm.
And they all originate at the centrosome. All right, what else?
Try these.
Oh, mitochondria. This is often people's number one takeaway when we ask them about the cell structure after this experience. They often say, I had no idea there were so many mitochondria, because they've seen all of these diagrams that have like one or two.
Okay.
Alright.
Let's try this one. Ooh, only a couple of those.
Alright, what did you,
I turned on, let me turn that again. Vacuoles.
vacuoles, alright.
I'm still around.
See if we can
So,
find some,
they go
oh,
right
there they are,
there.
green ones.
Cool.
Right.
Alright, we've also got, oh, I think that's left marvel. Let's try this one.
Okay, so that's the protein shell, and it makes it very difficult to see
Whoa.
anything else, but it
Ah,
shows you that
they're everywhere.
the cell is actually full of stuff, it's not just empty space.
Okay. What are those? What have I just done?
These are cilia, which, as I was just saying, actually should not be here,
Okay.
because this is still the model of the cell that the best science thought was connected to cystic fibrosis a year ago, and now we know that it isn't.
Is this meant to show like damaged or affected cells as well?
We're only showing you the diseased cell at the moment. That's something that we've considered changing so that you could toggle back and forth between diseased and healthy and look for
Yeah.
differences. But at the moment, we only show you the diseased and you're looking for clues.
Oh, interesting.
Right.
Okay.
What else you got?
What do we got here? Okay, oh, that's way back at the other end.
Oh, yeah.
We got.
Oh, the Golgi
Golgi
Body. So many things in the way. So the Golgi body's structure is more interesting actually from the top. You can look down into it.
Okay.
So this is something where I think it being 3D and in VR is helpful to just get a sense. Okay, what else you got?
There you go, blue one.
Oh, the nucleus, yes.
I think behind you. We have.
Ah, the ER. Great. So these little black things are ribosomes, and I can't click on them because they're actually at the same scale as proteins. So if you turn on the protein layer again, now the ribosomes light up,
Oh, I see.
and we can get more information about them. And this is a great transition point to nanoscale. So now I've just switched from micro to nano. So those same red things, the ribosomes, are now much bigger.
Oh, those are the protein clouds?
No, actually the blue you couldn't see before at all. Those are tRNA,
Oh.
and they have little amino acids on them that they're carrying around. And they bring the amino acids to the ribosomes during the translation process. This is mRNA. You can actually click on individual codons. And so those are getting translated into this amino acid chain. And I've actually slowed down time right now. I'll speed it up. You can see real speed, how quickly this happens. And I'll go inside the ER so you can see it from the other side as well. Okay, so we have a couple of amino acid chains here, and there should be a couple more coming. Oh, I see one coming here. Let me speed that up. Oh, my battery's low. There should be one more somewhere. there it is. Great, okay, so those are most of the features. I think at this point we can just open it up for anyone who is interested in trying it to come down. And I'll give you first dibs if you want to try the VR side.
I'm good.
You're good,
Yeah.
okay. See, as I said, not everyone wants to.
Yeah, it has that whole moving thing.
Yep.
I'm not doing the moving thing.
Okay, great, thank you so much.
Sure. Excellent. It was really cool to have
Yeah,
like
go ahead.
the text that you had displayed on the screen, which was hard to read for me
Mhm.
because it kept moving.
Mhm.
It would be great to have that mirrored somewhere
Oh.
on this
Watch out.
controller screen so that we could both actually
I
read it
can't
and
do
see
it for long, I will get sick.
Okay, do you want to do VR or tablet?
I'm
Or
gonna try VR.
you're going to try VR.
Yeah.
Have you used VR before?
Yes.
Okay, great.
I will get a little motion sick. but I'll
Okay.
be okay.
The main button, A, will move you forward
Okay.
and select things. B will transition you to nanoscale,
Ooh, okay.
but I'll remind you about that.
Okay.
A is your main one,
Okay.
and X is the clipboard.
So, okay, go for it. Alright.
So
Let's try.
might have to adjust.
The,
So the straps on the side will make it larger. There's one on the other side as well. Does anyone want to try the tablet while she's in VR? Danny? All right, come
how
on
do you
down.
adjust the focus?
So the focus, there's the interocular distance
Yeah.
under your right thumb. There's also how the position on your face, you can move it up or down a little bit and see if that helps.
Okay.
Get this out of the way.
How do I restart?
Um,
Oh, just done.
yeah, you can just uncheck them all.
Okay.
Oh,
Okay.
hands.
Your hands. How
Huh. Whoa. That's so cool.
is novelty effect?
Yeah.
How's the focus?
It's okay. My eyes are a little bit weird, so.
Okay.
Oh, cool.
So why don't you highlight a few things for her?
Okay. Are you ready?
Be 1 second. I'm gonna try to see if I can get this to be
Okay.
a little bit more there. All right, we'll do it. We'll do that. All right, cool.
So just highlighted the membrane of the actin. Do you see
behind here.
color?
I see this thread here. Oh no, that's not it. Is it over here? Is it back this way?
So yeah, the membrane is just the
Oh, you want the,
background.
oh, you want the middle, oh,
Yeah.
got it.
Okay.
Here you go.
Now
Oh,
I've
got
highlighted
it.
the Golgi body,
Or
which you're
sacrifice
on.
realistic numbers of things.
Okay.
So we decided that showing the right number was more important than showing the right number of polygons.
What do you think of this Golgi body?
So you'll see
I'm examining
hundreds of
all.
mitochondria, but they're all
Maybe.
almost, maybe it's 50.
Whoa,
polygons
that's
per-
way too close.
So yeah, there are definitely
Interesting.
more realistic representations.
And then how do I
Okay,
click
ready
it?
for another?
Oh yeah, go for it.
Structure?
Experience.
I'm gonna go back up to the
You
top.
also
Oh,
can't see
that
inside
one I got.
Yep.
any of the
How do I-
organisms.
How do
Whereas
I collect
often
you?
in the diagram they'll have a cutout, and then you can see like a little ribbon
Ah,
structure.
there we go. There we go. So,
but we
oh,
had
you're
to
not
cut that
membrane.
for performance reasons.
Intermediate filament.
Intermediate filament. There we go. Medium thickness intermediate filaments form a stable twisted structure and connect adjacent cells together.
Okay, ready for the next one?
Yes, we. Oh, got them.
Vacuoles, which are at the other end of the cell.
There are 3 clues. One is the channel protein, which is like a little doorway that goes across the cell membrane and
Interesting.
supports the transport of ions.
Alright.
It
Vacuole.
is
An animal.
a certain kind of
Nice. Vacuoles are
So
small
they
and
can
present
look for it
throughout the
and
cell.
not
They
find
are
it.
membrane bound sacs filled with fluid.
Okay,
And then
and
they
we're
look at
to
the
highlight
translation.
Oh, the
proteins.
Let's go into subspace.
Yes.
There's 2
Did I go into
problems.
subspace? Ooh. Oof.
You'll-
Well, what do you think about
you
being
can notice
immersed
that
in
the
proteins?
RNA does not accept full
Anytime.
The
What?
ribosome has two halves, and they just
How do I
Is it-
subspace? Where
Is
is
it like
this?
you're in a swarm of gnats or something?
It
So
feels
there's some
like,
reason that's happening early, and it's because there's
yeah, it
one
feels like I'm in
chromosome
a fluid that I can neither touch
is
nor
the
really
protein
experience, but I
that
see it, and it's,
stop translating.
Do you feel an emotional reaction?
yeah.
And then
I
the
don't think I
third
love
fluid
it.
is
Especially,
actually the
ooh,
resulting
I know I hate
proteins,
that actually.
the amino
Guys,
acids,
Do you want me to turn it off?
which makes sense because the
sure, wait, how do I go into like small space?
those are the
Okay.
I don't remember how to go into small space. This one? This one? No, that's just movement. No, oh well. I was trying to go into nano space to see if I can make them. Oh, that's really cool.
That would be great.
I like that it's
Another
right
thing that
here.
would be great is
Can you tell on the screen?
visualizing,
Yeah, I like that. That it, like, it feels like I'm actually a value.
because right now we just
Very
take you
cool.
out of the
Alright, do you want to highlight something else and then
back to the
Sure.
you can switch if
sort
you
of
like?
comic,
Lysosomes.
Alright, how do I get out of the protein view?
Yeah, so I guess having the option to
But
actually
to
start
see
making
it
changes.
in VR would be great. But yeah, it'd be a lot more work.
Meow.
How have you got
Meow.
I don't know, depends how long we can.
Clipboard.
focus on it.
Lysosomes.
So,
Lysosomes are
we've
responsible
worked
for
on it
digesting
a year
nutrients.
and a half,
Oh, nice.
and we have funding for this
Alright.
this year.
Do you want me to ask Dan to
Oh, to take the
coach
protein
you?
view? I just wanted to go to the nano view.
Yeah, sure.
Oh, oh no, that's.
Dan, how do we go to the nanoscale?
So go to the ER,
I have to go to the ER. Ooh.
maybe turn off the proteins.
How do you-
Okay, that's disorienting for her. Yeah.
Oh, perfect.
Okay,
Oh
so
my god, so much better. Alright.
go to, yeah, so you're at the wrong end of the cell.
Oh, I didn't know I had to be like next to the actual, what is it, the ER?
Yeah.
Okay, so the ER is going to be purple at the opposite end, the end that you started at.
Yeah.
We have just a few more minutes.
Oh, then would anyone else like to try?
To try? If you change your mind later, you are welcome to come to
Was that
my
no one?
office,
Did no one want to keep going?
which is in
Wow,
Tech
that's-
Square.
Did you wanna
in
try?
Tech Square.
No, thanks.
And that's
Right.
where
If,
this is.
if you want
Most of the
to,
time.
do you want to keep going?
Did no one else want to try?
No one else want to try? Yeah. No one is as brave as you. Oh,
Okay. Cool. Yeah. Oh, it's very fun.
Do you want to switch to the tablet?
Oh, yeah. Oh, I can let someone else do it. Ooh, I am
You're dizzy?
deeply motion sick.
Sorry to hear that.
No, it's just how VR works.
Oh, yeah, no problem.
As
Yep.
well.
Have you used Oculus Rift before?
I have, yeah,
Great.
yeah. I've made a couple things in Unity and for Oculus.
I think it's more
Welcome
comfortable
to-
sitting down.
Yeah, I totally agree.
So
So
just tighten the straps on the side so it's comfortable.
I'll sit.
Okay.
Yeah, this is great.
Here's
Thank you.
that hand and that hand.
Thank you. Awesome.
Under your right thumb, the A button moves you forward. That's, yeah, that one.
Okay, awesome.
Let me
Okay.
turn on a few things. Last call on the tablet. Anyone want to see that? And any last questions?
Was the movement always the same as it is now? I know.
We experimented with a few movement systems. There was one that we called the holodeck, where you were standing on a platform and manipulating the cell with these kinds of gestures. And we found that when the cell is very small, that feels great. But when the cell is very big, it feels very disorienting to have these kinds of movements. So we ended up going with the approach that we call the Spider-Man, where you just like point and go in the direction that you pointed. One test that I would like to do this summer maybe with the Oculus Quest is setting it up in a larger space and just having, walking to move through the cell as opposed to any button mapped to that. We would still need some way to change your Z position, so we'd probably have a button for that. But I'd say we're still experimenting with movement systems. Good question.
This is really very interesting.
Okay.
Sorry.
I am going to start packing up.
Yeah, sure.
But thanks for trying.
Thank you for letting me try it. That's
Yeah.
really cool. Wow. Yeah. And you said you've been doing this project for a year and a half?
This is about a year and a half. Yep.
Okay, cool. That's awesome.
And I should also say that it's supported partly by Oculus.
Okay, right, okay. That's awesome. What's the project called again?
It's called CLEVR, which stands for Collaborative Learning Environments in VR. And that's the overall project. And then the cell game we call Cellverse.
And you've been working on that here then, right?
Yeah. Yeah, I'm a research scientist in a lab called the Education Arcade.
Cool.
Thanks, Dan.
Yeah, thanks.